Hello, hello. Testing. Please let me know if you can hear me and if everything's okay. I'm just checking my stream. All right. Hello, everyone. So today, as you may have noticed, my setup is very different. Unfortunately, my computer died, and so I'm working on an old laptop. Well, it's not old. It's just not very good. So if the stream dies midway, you will know why. And, I guess that's life. All right. Hello, Mohammed, and hello, Overcheck-in. Nice to see both of you. I was just explaining that my computer died. I'm working on a not very good laptop. So there is a good chance that the stream will die midway. So for today's stream, hold on. Overcheck-in says, "Hey man, I've been enjoying thinking about the coin flipping problem you posed. I'm happy you enjoyed it. Please let me know what you think about it. And hello, Urist McFarmer. Nice to see you. So I wanted to redo a high school math exam that I did back when I was fresh off the boat. I just immigrated to the United States. I've come from India originally, and on this test, I did okay, but I did not do that well. So if you're not familiar, quote unquote talented American math high school students, they take this sequence of exams. They start at the AMC. If you do well on the AMC, you take the AMY, which is the American Invitational Math Exam. And if you do well on the American Invitational Math Exam, you get invited to the next level. Then there's another level. Then there's another level, and then eventually there's the International Math Olympiad. So this test is used to identify kind of talented American math high school students. And I went to a specialized math and science academy. So for me, this test was actually also used to decide who would be on my school's math team. And unfortunately, I did not do well enough to make that team. So I was curious. I've been trying to think more and more about competitive math, like the type of math that appears on math contests. I'm still not 100% sure how I feel about it. And I'm curious to see your guys' thoughts about competitive math. I mean, some people don't like it very much. Some people really love it. There have been some fantastic mathematicians that come from that tradition of doing a lot of contest math and contest prep. I never prepped for any of these. I actually wasn't even aware that you were supposed to do stuff like that. So, hold on, I have another comment. Sorry, I'm reading the comments on my phone because, like I said, my computer is dead. So, let's see. I was able to deduce a formula for the probability of winning given the number of flips and the probability of heads. Haven't been able to maximize the formulas yet. Yeah, I see. Well, I did post all the solutions, but I'm happy to give you more hints if you leave a comment after this video. In any case, let's get to it. So the contest that I did was AMC. I believe it was 2006. And, all right. Hold on. I think I need to type AMC 12, 2006. This AMC 12A problems. All right. Are you guys excited? So this is a 75-minute test. Okay? And I was thinking in the stream you could try to, I don't know, maybe you could try to keep up with me. I'm not sure what would be most fun for you, but I'll get started in a minute. So let me just explain the rules. There are 25 questions. The test is 75 minutes long, so that's 3 minutes a question. But just so you know, the last couple of questions are, I think, hard. So try to do the first, maybe try to do the first 10 or so quickly. I guess we'll be doing it together. It's kind of weird. I don't know. I never quite figured out the formula for problem-solving streams, but let's see. So I would say the first couple are just about who's a faster calculator, but then the last couple always involve a certain amount of ingenuity. So and by the time you get to the last couple, they are significantly hard. I'll tell you what my interest in this is. I'm still not sure how I feel about math contests. I did pretty well in math. I got my PhD. I did well with research or whatever. But I never like explored that side of mathematics very much, so I'm not really sure how I feel about it. One thing I'm definitely curious about is whether or not these tests are quote unquote culturally fair, or like so there's this thing with the IQ tests where it's very hard not to test people on information that they may have just picked up on. Like if you take a lot of online IQ tests, they'll ask you something about like what is a Fibonacci sequence or something, and then it's like the people who already know what a Fibonacci sequence is will identify the pattern immediately, but the people who don't might not be able to. So I'm just the quote unquote fairness of it, or like how much mathematical experience matters on these tests, is interesting. In any case, let me know whenever you guys are ready, and I'm about to get started. So let me open a Paint document. I have not looked at these in advance, just so you know. I'm just going to open a Paint document in the background. I'm going to use it to record my answers. Let me just make it like bigger. Sorry I don't have my usual setup today. I'm just working on like a not very good laptop. So let's see here. And if you're watching this later, I've definitely timestamped the video so you can just forward to where the test starts. All right. Are you guys ready? Okay. Just so you know, only like a couple of kids in the country get a perfect score, and I think maybe like 10 to 20,000 kids take or like qualify to take this exam. Though I'm not 100% sure about those numbers, so don't quote me. All right, ready? On your mark, get set. Oh my God, it's not scrolling. Okay, it's scrolling. All right, go. Sandwiches at Joe's Fast Food cost $3 each, and sodas cost $2 each. How many dollars will it cost to purchase 5 sandwiches and 8 sodas? So 5 sandwiches are $3. That's 15. 8 times 2 is 16. 15 plus 16 is 31. So 1 is A. All right, next one. X tensor symbol y is x cubed minus y. What is h tensor h tensor h? So that's going to be like h cubed minus h. And so you have h cubed minus h cubed minus h. So the h cubes cancel. You have plus h. So 2 is C. Okay. Next one. The ratio of Mary's age to Alice's age is 3 to 5. Alice is 30 years old. How old is Mary? So Mary over Alice is 3 over 5. And then Alice is 30. So it's 3 over 5 equals m over 30, which means m is 90 over 5. 90 over 5 is 18, so it's B. 3B. Okay, so a digital watch displays hours and minutes with AM and PM. What is the largest possible sum of the digits in the display? Okay, let me think about this. So 1259 would be 1 plus 2 is 3, and then 5 and 9 is 14, so... Oh, wait, oh my God, they almost got me. So it's 9:59 will be the largest time. So 9 and 5 and 9 would be 23, so 4 is E. Okay, so, all right. Doug and Dave share a pizza with 8 equally sized slices. Doug wanted a plain pizza, but Dave wanted anchovies on half the pizza. The cost of a plain pizza was $8, and there was an additional cost of $2 for putting anchovies on 1/2. Dave ate all the slices of anchovy pizza and 1 plain slice. Doug ate the remainder. Each paid for what he had eaten. How many more dollars did Dave pay than Doug? Let's see. So, and yeah, about the stream quality, I'm using an old laptop, so I might just have to delete this stream entirely, to be honest. But we'll just, we'll have to see how it goes. I'm not sure how good the encoder is on this laptop. It just might not be able to do anything. But we'll see what happens. So where was I? So Doug and Dave share 8 equally. So how many more dollars did Dave pay than Doug? So it's $2 extra for the anchovies and $8 otherwise. So it's $1 a slice without the anchovies, and then the anchovies add 25 cents a slice. So if Dave ate 4 slices of anchovy, that's like $6. Oh, hey, Brian. So that's $6 in anchovy plus an additional $1, so that's $7. And then the other guy ate $3 worth of pizza, so the difference is 4. So it's 4. 5D. All right, let's go. We're warming up. We're getting warm here. So an 8x18 rectangle ABCD is cut into 2 congruent hexagons as shown in such a way that the 2 hexagons can be repositioned without overlap to form a square. What is Y? So let's see. So you can reposition these to form a square. So if you reposition these to form a square, oh, it'll be like a oh no, it won't be 8x8. Oh, but this, if this is Y, this is Y. So that means the middle thing is Y, which means that 18 is 3Y, so Y is 6. So 6 is A. Okay. God, I don't think I'm banking enough time. All right. So Mary is 20% older than Sally. Sally is 40% younger than Danielle. The sum of their ages is 23.2 years. How will Mary be on her next birthday? All right, let's go. So Mary is 20% older than Sally. So M is 1.2S. And let's see. Sally is 40% younger than Danielle. So S is 0.6D. So the sum of their age is 23.2. So let's see. Let's convert it all to D's. So this is 0.6D plus Danielle. So this is Danielle. This is Sally, and then Mary would be 1.2 plus 1.2 times 0.6, which is 7.2. So 7.2 D. So that's let's see, 9. Wait. So that's 7.8 D. So 8.8 D. 8.8 over 23.2. Oh my God, the arithmetic is killing me. Let's see. Am I doing this right? 1.2 times 0.6 is 7.2. This is Danielle. This is Sally. This is Mary. So this is 7.8. So it is 8.8. So it's 23.2 over 8.8. What is that? So is this divisible by 11? Oh, it is actually. So this will be like 8 and 23.2. So this is, God, my arithmetic is so bad. Plus it's like so nerve-wracking. Oh no, man, I'm doing something wrong here. I can't quite spot it. I guess I'll come back to this one. So problem 8. How many sets of, so hold on, let me mark that I skipped 7. I think I'm getting nervous. But I'm going to mark that I skipped 7, so question mark. It's easy, I'm like getting flummoxed. So how many sets of 2 or more consecutive positive integers have a sum of 15? Well, okay, so you have 1, 2, 3, 4, then you have 7, 8, right? But you can't have, 1, 2, 3, 4, 5, and then you have 7, 8. So that's 1, but then 2, 3, 4, 5 is not going to work. 1, 2, 3, 4 is not going to work. 2, 3, 4, so how about 3, 4, 5, 6? 3, 4, 5, 6, this would be 7 plus 11, which is 8, so it's over. So there are no sets of 4 that are going to work. Are there any sets of 3 that are going to work? So 3, 4, 5 is too low. 4, 5, 6, so 4, 5, 6 works. So there's 1 set of 5, 1 set of 3, 1 set of 2, and 1 set of 1. So 8. There are 4 sets. 4. 8 is D. So 4. Oh wait, I'm in the right place. All right. So Oscar buys 13 pencils and 3 erasers for $1. A pencil costs more than an eraser, and both items cost a whole number of cents. What is the total cost in cents of 1 pencil and 1 eraser? So let's see. Let's see. So 13 pencils, 3 erasers. So let's see. They cost $1, and it's a whole number of cents, but the pencil cost is greater than the eraser cost. So let's see here. So I think it's better to start counting multiples of 3 going down. So let's see. So for 3, it's 13. I'm sorry. It's better to count multiples of 13 going down because the number of pencils is greater than the number of erasers. So 13 times 7 is 91. 7 and 3 works. 7 and 3 works. So 9 is A. Okay. All right. For how many real values of x is the root 120 minus x an integer? Let me just take a peek at oh my god, the comments. Yeah, I get very anxious on these tests, which probably also explains why I don't do so well on them. I should just retitle this like anxiety to stream. But let's see. For how many real values of x is root 120 minus root x an integer? So it's going to happen whenever root 120 minus root x is a perfect square. And there are, the square of 11 is over, and there are 11 squares. So yeah, you could do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 11 squares. So it should be E. 10 should be E. All right, let's go. So which of the following describes the graph of the equation? They're getting a little harder now. How you guys doing? Let's see. So which of the following describes the graph of the equation x plus... So someone said, this stream is bringing up some... Oh, trust me, it's bringing up some painful memories for me, too. So let's see. So x plus y quantity squared equals x squared plus y squared. And how do you graph that? You expand. And then if you expand, then the x squared and the y squared. So 2xy is 0. 2xy equals 0 is 2 lines. 11 is C. Okay. All right, let's go. God, this computer sucks. Okay, so a number of linked rings, each 1 centimeter thick, are hanging on a peg. The top ring has an outside diameter of 20 centimeters. The outside diameter of each of the outer rings is 1 centimeter less than the ring above it. The bottom ring has an outside diameter of 3 centimeters. What is the distance in centimeters? From the top of the top ring to the bottom of the bottom ring. Okay, so I think I'm gonna add. I'm just gonna add all the things, and then I'm gonna subtract what they have in common. So I can add all the numbers. 20 to 3 going down. Okay, one mistake I always make is I always do bad with like inclusive counting. So I'm actually going to count it on my fingers. So 3 to 20 is either 17 or... Okay, no, I don't need to count it on my fingers. It's 18 rings. It's 18 rings. Okay, so it's 18 rings, and so 20... So I'm adding the numbers 20 down to 3. So that's just 23 times 18 over 2, which is 23 times 9. So 23 times 9 is 180. Am I doing this right? 23 times 9. 9 times 3 is 27. So 207 for that. But then you need to subtract this. You just subtract the stuff in the middle. So there's 17 things in the middle, and then each of the things is 2 centimeters apiece. So it's 17 times 2 is, oh my god, what's 17 times 2? 34. So 34, and so it should be 173. Is that an option? It's an option. It's an option. Okay. So 12 is B. What is happening to my life? All right, problem 13. How are we doing on time? I think we're doing okay on time. All right, let's go. So, problem 13. The vertices of a 3, 4, 5 right triangle are the centers of 3 mutually externally tangent circles as shown. What is the sum of the areas of the 3 circles? God, I dropped my pen. Okay, so What? What's going on here? Oh, it's a system of equations. It's a system of equations. So, because if you set the radius of A to be x, and the radius of B to be y, and the radius of C to be z, then x plus x plus y is 3. Oh my god, I need to write this down. My brain is dead. So x plus y is 3, and y plus x plus y is 3, and x plus z is 4. And y plus z is 5. Oh my god, this is 1, 2, 3. It's 1, 2, 3. So x is 1, y is 2, z is 3. Okay. So what is the sum of the areas of the 3 circles? 1, 2, 3. So the area of A is just pi. The area of B is going to be 4 pi. The area of C is going to be 9 pi. So 1 and 4 and 9, 14. It's 14 pi. It's E. Okay. 13 is E. All right, let's go. All right, problem 14. 2 farmers agree that pigs are worth what are they talking about? 2 farmers agree that pigs are worth $300 and goats are worth $210. When one farmer owes the other money, he pays the debt in pigs or goats with change received in the form of goats or pigs as... Oh my god, I'm not understanding any of this. So 2 farmers agree that pigs are worth $300 and that goats are worth $210. When one farmer owes the other farmer, he pays the debt in pigs or goats with change received in the form of goats or pigs as necessary. For example, a $390 debt could be paid with 2 pigs with 1 goat received in change. What is the smallest amount of positive debt? It's just the smallest linear combination that you can write. It's just like, this is cold. This is a cold problem, because this is just a fact in number theory, that the GCD of 2 numbers is the smallest number that you can write as. So, okay, this one's cold. This is not a good, I feel like this is not a good problem, because if you happen to know the fact, it's super easy. But if you don't know the fact, it's really hard. But 14 is C. Okay. Suppose cosine x is 0, cosine x plus z is 1/2. What is the smallest positive value of z? Okay, I'm either doing angle sum or I'm drawing a unit circle. Let's try angle sum. So cosine x plus z is cosine cosine minus sine sine, right? So cosine x plus z is cosine x cosine z minus sine x sine z. All right, so this is 0. So you want negative sine x sine z. This is not working. I don't know what I'm doing. If cosine x is 0, let's unit circle it. If cosine x is, I'm drawing a unit circle. If cosine x is 0, then that means that the point is either here or here. There it is. Okay. And then if cosine x plus z is 1/2, that means x plus z can be here or here, right? Because these are the only points with an x coordinate of 1/2 on the unit circle. But if this is where x is and this is where x plus z is, you can't do the top one, because for the top one that doesn't make sense. I guess z could be negative. What are the positive value? They only want positive value, so only the bottom bit makes sense. So this is a 30, 60, 90 triangle, where the 30 is here. So 30 degrees is pi over 6, so the answer is pi over 6. A. 15 is A. Too old for this. All right, let's go. All right, circles with center A and B have radii 3 and 8, respectively. A common internal tangent intersects the circles at C and D, respectively. Lines AB and CD intersect at E, and AE is 5. What is CD? Is this a power of a point thing? God, how do you do power of a point? Oh my God, I don't remember how to do power of a point. How do you do power of a point? Okay, I know, I can't get distracted. How do you do power of a point? Okay, no, I remember how to do power of a point. So, AB, God, I need to read the problem. So circles with center A and B have radii 3 and 8, respectively. Okay. A common internal tangent intersects the circles C and D. Oh my God. Okay. Hold on. I'm being informed that I have crashed. Hello, is everyone there? I just got a message saying that I crashed. Let me just someone type something in the chat if I'm still live. I assume I'm still live, but I don't know. Okay. All right. I think I'm back. Okay. All right. What was I doing? Yeah. Oh yeah. Reading the problem. So circles with center A and B have. Oh, my mic is loud. I'm sorry. Let me put it away from me. Let me know if that's better. So circles with center A and B have radii 3 and 8, respectively. A common internal and tangent intersects the... yeah, it's this... I'm using a really old laptop, and... yeah, my computer exploded, so I'm using a really old laptop. And so you are hearing the amazing fans whirring in this super-duper old laptop. Let's see here. So circles with center A and B have radius 3 and 8, respectively. Do let me know if the stream is even watchable. If it's not watchable, I'll probably take it down. So 3 and 8, respectively. A common internal tangent. AE is 5. What is CD? Oh, they're similar triangles. They're similar triangles in this picture. Okay. Let me man, it would be nice if I could just like draw on the test, but I think I have to redraw the picture. So this is A. This is the other one. And then there's a line that cuts through here. And then there's a thing here, right? And then, right. There's similar triangles in this picture. Watch. So there, so this, you got this, and then you got this, right? And this here is the radius 3, right? And this one here is 8. And these two triangles are similar because they share an angle, and these two are right angles. So, let's see. What is, wait, what else do we know? We know that AE is 5. So AE, what is AE? AE is this one. So this one is 5. This is a right, this is a very poorly drawn right triangle, but it's a 3, 4, 5 right triangle. So there it is. 3 is to, wait, what are we finding? We are finding CD. So CD is this one. So we're looking for this one. There it is. Okay, so 3 is to 4 as 8 is to mystery number, which means 3 over 4 equals 8 over x. I should have written it as whatever. 8 times 4 is 32. So this x is 32 over 3. And then, so this big segment is 32 over 3 plus 4, which is 12, so 44 over 3. 16 is B. All right, let's go. We're picking back up. All right, problem 17. Square ABCD has side length S A circle centered at E has radius R. R and S are both rational. The circle passes through D, and D lies on BE. Point F lies on the circle, the same side of BE as A. Segment AF is tangent to the circle. AF is R over S. I don't know. AF is that, let's see here. Oh, I actually can draw in the picture. Hold up. Let me just take a little snapshot of it with my Windows snapshot tool. Copy. And I can put this thing, let me clean up paint a little bit. Put this thing in paint. Okay, so the side of the square is S, and the radius of the circle is R, and let's see here. AF is root 9 plus 5 root 2. So root 9 plus 5 root 2. And then, what else do we know? What other information do we have? So, point F is on the circle on the same side of BE as A. Okay. The circle passes through D, and D lies on BE. Okay, so that's good news. So this is a straight thing. So that makes this one S root 2. Okay, so that makes this one here R over root 2 plus S. Okay, so if this is R over root 2 plus S, and what am I doing? R over root 2 plus S, and then this one. Oh, wait a second. So this, I think I can compute what that is. So, okay, so that segment in there is a part of a right triangle. So, that segment over there is the same as this segment down here because it's congruent. And so, let's see here. This is R over root 2 at the bottom here. So that's R squared over 2 plus, and then this is R squared over 2 plus S squared plus 2, so root 2 RS. Okay. So this thing here is, which is equal to that diagonal over there, is going to be R squared. Well, it's square anyway, so it's going to be the square root of R squared plus S squared plus square root 2 RS. Okay, but then you have another right triangle here, which gives you a second system of equations. And so what you basically know, man, I hope I set this up correctly. I might have to revisit this one. See, this is why you need to bank time, because there are awful ones lurking. So, no, that doesn't quite. I'm gonna have to revisit this one. I think you have to. I think you have to put this in the coordinate plane. So 17 is a question mark for me. All right, let's move on to 18. The function f has the property that for each real number x in its domain, 1 over x is also in its domain, and f of x plus f of 1 over x equals x. What is the largest set of real numbers that can be in the domain of f? let's see. So, I think you can replace. Oh, this identity. Well, the left-hand side is symmetric if you replace x with 1 over x. So that just gives you x equals 1 over x. And x equals 1 over x is only true for 1 and negative 1. So 18 is E. Okay, 19. It's another geometry one. I've not been having good luck with geometry. Circles with centers 2, 4, and 14, 9 have radii 4 and 9 respectively. The equation of the common external tangent to these circles can be written in the form y equals mx plus b with m greater than 0. What is b? Okay, there's what is the double angle formula for tangent? I think that's what you need here. Oh my god, I can't believe I'm forgetting this. I'm just a wreck. What is the double angle formula for tangent? That's what we need here. Tangent 2 alpha is... Oh my goodness, I can't believe I'm forgetting this. Whatever, I think I can just cheat. So, let's see here. This one is, let's see, you got a circle. Well, okay, I don't even need to worry about the circles at all. So this is 2, 4, and 14, 9. So the slope here is 9 minus 4, which is 5. 5 over 12 is the slope here. Oh my god, this is screaming some right triangle energy to me. So 5 over 12 is the slope of this line. Right? And then the slope of this line is, okay. So this angle is the inverse tangent of 5 over 12. And then we are interested in this line here, like going here, where this angle is also the inverse tangent of 5 over 12. Let's see. Okay, so how do you double? Okay, I can't believe this. So tangent 2 alpha equals, man, what was it? I think it's 2 tangent alpha over 1 minus tangent squared alpha, is that right? I could test it for an easy one. So for example, the tangent of 90 degrees what? Okay, I'm gonna gamble. I'm gonna say that this is right. So we are interested in the slope of this line, which is going to be, I just need to plug in this business. So this is 2 times 5 over 12, which is 10 over 12, over 1 minus 5 over 12 squared, which is now 25 over 144. Okay, so 1 minus, so this is 144 minus 25. Where's 144? Minus 25. So it's 124 minus 5 is 119. So this is 119 over 144, 10 over 12. And so this is, also 10 over 12 is just a 5 over 6. So let's see here. So this is 144 times 5 over 119 times 6. If I'm using the correct double angle identity for tangent, which I'm not 100% sure that I am. So yeah, it's 144 times 5 over 119 times 6. That would be the slope of this line. So using point slope, we also need a point that this thing goes through. So the line that had slope 5 over 12, the line that had slope 5 over 12 passes through, let's see here. Okay, I'm going to try moving my mic. Let me know if that improves. Yeah, let me know if that improves anything. I think it's the like fans on my whatchamacallit, laptop. Okay, so 5 over 12, it passes through 2 comma 4. So let's see here. So x minus 2, y minus 4 equals, so that means, let's see, y equals 5 over 12 x minus 10 over 12 plus 4, which is 4 times 12 is, so that's 38 over 12. That, so we just need to solve for where y is equal to, where the x-intercept of this is. So this is going to be, you set y equal to 0, so you get negative 38 over 12, 12 over 5. So negative 38 over 5, I guess, is the x-intercept here. Okay. I think I'm spending too long on this problem. I'm going to have to return to it. I think I'm very close, but I just need to, yeah, I feel like I'm spending too long on this problem. So, all right, let's do problem 20. Oh man, I see 119s. I do think I'm close. I'm just skeptical that I'm using the correct double angle formula for tangent, but let's see. A bug starts at one vertex of a cube and moves along the edges of the cube according to the following rule. At each vertex, the bug will choose to travel along one of the 3 sides emanating from that vertex. Each edge has equal probability of being chosen, and all choices are independent. What is the probability that after 7 moves, the bug will have visited every vertex exactly once? Okay, so let's see here. How many, Hamiltonian type pads are there on a cube? Because a bug is only making 7 moves. So let's see, it's like, you have like that, right? That's 1. But then how many ways can you like flip this? So if you keep this for one face, so this is like, for example, you can imagine I'm like drawing a cube, and then the bug could travel, for example, like that, right? And I'm pretty sure all Hamiltonian pads on a cube look like this up to symmetry. And so, but then even for a given face, you can rotate this. I think in 3 ways without overcounting. And so I think the total number of good pads is 18. Okay, so there's the total number of good pads for the bug is 18. What is the number of possible pads? Well, each, it's like 18 over 3 to the 7 or something. But 18 itself is 3 squared times 2. So the answer is going to be 2 over 3 to the 5. 3 to the 5 is what? So 3 to the 4 is 81, and 3 to the 5 is 243. It's C. 20 is C. I made such a mess with the last problem. I'm hoping I save a little bit of time so I can revisit some of the ones that I missed. I should be able to revisit 7. Let's see. So 20 is C. All right, let's go. Problem 21. Let's see. Let S1 equals this set and S2 equals this set. What is the ratio of the areas between S2 and S1? Let me just copy this in so I don't mess it up. Okay, so S1 is this. So that means I can raise both sides to 10. And basically this is telling me that 1 plus x squared plus y squared is less than or equal to 10x plus 10y. Pushing that to the other side, this tells me that x squared minus 10x plus y squared minus 10y plus 1 is less than or equal to 0. And so what we want to do here is complete the square for both of these. And so, let's see. So I add 25 for both of these to complete the square. So it's x squared minus 10x plus 25 plus y squared minus 10y plus 25. And then to do that, I need to subtract 25, so that's 50, and so it's less than or equal to 49. So it's like x minus 5 quantity squared plus y minus 5 quantity squared is less than or equal to 49. So the first one is a circle of radius 7, so its area is 49 pi. 49 pi is the area of S1. What's the area of S2? Let's see here. S2 is, let's see. So in this case, it's like 2 plus x squared plus y squared is less than or equal to, I guess, 100x plus 100y. Okay. So I can do it again, and so I have x squared plus, minus 100x. And this is plus y squared minus 100y plus 2 is less than or equal to 0. All right, so what is going on here? How do you complete the square for 100? So you just divide it by 2. So it would be like 2,500, I think. So yeah, that's right. So it's plus 2,500. And then plus 2,500 plus 2,500 is 5,000. Am I being an idiot? Let's see. X minus 50 squared. No, that's right. That's right. So you do need to add 2 copies of 2,500. Okay. So you get x minus 50 squared plus y minus 50 squared is less than or equal to, so this would be 5,000 minus 2, which is 4,998. So it's like 4,998 pi. So what would the ratio be? (49 times 102 is, okay, so 21 is E. Okay. We're doing okay. 21 is E. I think I have, I'm not really sure when I started, but it can't, I mean, I start the streams at 1, and I usually like ramble for 5 minutes. So I think I'm doing okay on time. But as you can see, these problems are getting significantly worse. Let me know if the noise has gotten better at all. So let's see. So a circle of radius r is concentric with an outside irregular hexagon of side length 2. What is the probability that 3 entire sides of hexagon are visible from a randomly chosen point on the circle is 1/2. What is r? Okay. So there's a hexagon sitting inside a circle, and you take this point. What does it mean for 3 entire sides of the hexagon are visible? Let's see. 3 entire sides of the hexagon are visible. I'm not sure. I'm not sure how to approach this one. I think I'll have to come back to this one. Let's see. So this was at 22. The mic would be better if you brought it closer to your mouth and turned it down in OBS. Let me try that. Okay, I put it down. -5.8. And I'm bringing it closer to my mouth. Please let me know if that helps. All right. So, all right, yeah, 22 I skipped. Let's try 23. Given a finite sequence S equals this of n real numbers, let AS be the sequence. So what are you doing? Oh, you're doing like averages. Okay, so the first one, yeah, please do let me know if that helped at all. That helps a little, okay. All right, I'll put the laptop further away. See if there's like... Let me know if that helps. I like changed what mode the mic was on as well. Okay, wow, all right, I'm happy I did something. All right, so you're given a finite sequence, a1 through n of n real numbers. Let AS be this sequence. And then you, of n minus 1 real numbers, define a1s equals as for each integer m. Okay. So you're doing like recursive averaging. A to the 100s is 1 over 50. Oh, I see. So every time you do it, the number of terms in the sequence goes down by 1. Also, you're going to see a binomial thing here too. So a1 plus, oh, okay. Watch. So this is 1, this is 1, 1. But the next time you do it, it'll become 1, 2, 1. Because the first term of the sequence will be like a1 plus 2a2 plus a3 over 4, right? Which is 1, 2, 1. And then the next time it'll be like 1, 3, 3, 1. And then the next time it'll be 1, 4, 6, 4, 1. Then 1, 5, 10, 10, 5, 1. And so on. So, okay. That's good. So it's binomials. It's just binomials. So this is, you're starting with 1 to x to the 100. And so a to the 100s will just be like, let's see if the indices line up with the, so AS is, oh, even the indices line up perfectly, man. They line up perfectly. Okay. So a to the 100s is just going to be the sum of like n goes from 0 to 100 of 100 choose n x to the n, which is just 1 plus x to the 100. So 1, over 2 to the 100. So this 1 plus x to the 100, 1 plus x to the 100 over 2 to the 100 is equal to 1 over 2 to the 50. What? Okay, sure. And so this equals 1 over 2 to the 50. And let's see. So that means, but that's none of the answer choices. What am I doing? I thought I was so good with this one. really thought I had this one. Yeah, it's going to be 1 plus x to the 100. Oh, I didn't do anything wrong. I'm just not reading the question. So based on what we just did, 1 plus x to the 100 is 2 to the 50. There it is. And that means 1 plus x is root 2, and x is root 2 minus 1. All right, perfect, perfect. So 23 is b. So 22 we skipped. 23 is b. Let me tidy up a little bit. All right, I banked a bit of time. I think I have about 15 minutes left. Hello, Ken. I'm doing a high school math exam. Feel free to join in. All right, we're on the last two problems. These are going to be hard. Let's see. So the expression x plus y plus z to the 2006 plus x minus y minus z to the 2006 is simplified, and you combine like terms. How many terms are there in the simplified expression? Okay, there's going to be a lot of cancellation. Right? So if you expand, let's see, x plus y plus z to the 100, you get the sum of like I plus j plus k equaling 2006 of the multinomial coefficient 2006 I, j, k. X to the I. This is, I can't believe they give this to high school students, man. This is crazy. This is crazy. Okay, I guess it is the last problem, but, or like we're getting close to the last problem. So let's see. And then x minus y minus z is to the 100 is like the sum I plus j plus k, the multinomial coefficient ijk, x to the I minus y to the j minus z to the k. Now, most of these will cancel, right? So it'll cancel whenever j plus k is odd. Okay, so you cancel whenever j plus k is odd, you get a negative here, and the corresponding term will cancel. So you're interested in so the number of terms will correspond to, if you're subtracting these two, it'll correspond to all the j plus k's where j plus k is even. So we just need to answer the question, how many ways are there to add I plus j plus k to 2006 in a way so that j plus k is even? Well, if j plus k is even, that means I is even. So we can just figure out the number of ways to add I plus j plus k to 2006 in a way where I is even. Okay, so let's see here. If you fix I, so I can be like 0, 2, 4, 6, all the way to 2006. Let's see here. So Ken, this is like to test math students to like go on and do competitive mathematics. And just so you know, the last couple problems are always a lot harder than the first couple. The first couple were just like, what's 6 times 3 or whatever, you know? So, but yeah, so like there's a whole sequence of these tests. As you take them, they get harder and harder, and eventually you qualify to take the International Math Olympiad if you're like Terrence Tao or whatever. Okay, so what was I doing? So I can be all these things, and j plus k, well, how many ways are there to choose j plus k? Well, j plus k I can do whatever, so there's going to be, let's see, 2007 ways to do j plus k, I think. I hope I'm not being bad. And then there's going to be like 2005 ways to do it here. And then there's going to be one way to do it down here to do the j plus k split. So I'm basically adding all the odd numbers 1 through 2007, I think. I hope I'm not messing this up. So okay, so that should just be, it's like if you add, yeah, 2001, 2007 and 1 is 2008. So I can do 1004 times 1003 is going to be the answer. Now, what the heck is 1004 times 1003? So it's going to be like 1000 plus 4 times 1000 plus 3. So like 1,000,000 plus 4,000 plus 3,000 plus 12. Is that even one of the choices? You know what? I'm gonna say C. I think C is the closest to my, I feel like I was very close. I'm not sure where my arithmetic got messed up. So okay, I'm gonna say C, but it's tentative. So 24 is C. I really thought I had that one in the bag. What am I doing wrong? Should it be? Whatever. I'm rolling with it. Let's do the last problem and see what we get. By the way, just so you know, only like a couple kids get them all right. And yes, I know I'm competing against like high school students at this point, but you know, let's let's go. So 25 is how many non-empty subsets of this have the following two properties? No two consecutive integers belong to S. If S contains K elements, then S contains no number less than K. Let's see. No two consecutive integers in S. No number less than K. If S has K elements, you can't have any number less than K. Okay, I think this one's easy. So you just need to add binomial coefficients. And once again, it's crazy they're giving these problems to high school students, man. I don't even know what to tell you. I'm very impressed. I mean, if you did well on this kind of test, like good for you. Like give yourself a pat on the back. This is amazing. So if you're picking a single element, there's just 15 ways to do that, right? If you're picking a two-element set, how do you do this? No two consecutive integers belong to S. Let's see. Man, there's definitely an easy way to do this. Yeah, it's like I'm picking numbers 2 through 15, but I can't pick two numbers that are next to each other. How do you do that? I'm picking numbers 2, 3, all the way through 15. I can't pick them next to each other. Man, there's like a way to do this. Just blanking right now. It's gonna be like 13. Am I losing my mind? I feel like this is not hard at all. Okay, if I'm picking... I don't know what to say. I think we're leaving 25 blank as well. All right, so what do we have to do? I think we can fix 7 really easily, because there's a... Yeah, I just got nervous right at the start. It was a really easy problem. Let's see. So Mary is 20% older than Sally, and Sally is 40% younger than Danielle. The sum of their ages is 23.2. Let's see. So Mary is 20% older than Sally, so 1.2s. Sally is 40% younger than Danielle, so Sally is 0.6d. So the sum of their ages is 23.2 years. All right, let's see. So we can convert everything into Danielle ages, and so Mary is so it'd be d plus 0.6d plus 0.6 times 1.2 is 0.72 d. So putting this together, we get 1.32 for these two. I guess, oh my goodness, 2.32. How did I get this wrong the last time? I have no idea. So 2.32 d is the sum of their ages, which means that Danielle is 10, and what are we doing? Mary is going to be 7.2 years old. If Mary is 7.2 years old, she'll be 8 on her next birthday. So 7 is B. How did I... Man, I hope I got it right, but I'm... It just goes to show what happens when you're nervous. So 7 is B. All right, let's see. All right, let's see what other ones we missed. We still have a couple minutes, I think. So we got 1 through 14. I had trouble with 17, 22, 24, and 25. Let's see. Let's go back to 17. Uh, 17. Okay, yeah, this one. I think I'm going to try coordinates this time. So I'm just going to take a picture of this. Let me reread the question, make sure there isn't something I'm missing. Let's see here. So ABCD has side length S, circle centered at E has radius R and S are both rational, a circle passes through D lies on BE. Segment AF is tangent to the circle. What is R over S? So AF is root 9 plus 5 root 2. Okay. So let's do coordinates. So B is 0, 0. Then that makes A 0, S. Not 0, 5. That makes A 0, S, which makes E, so this point over here has to be S root 2 plus R, comma S root 2 plus R. Okay, and then, so those are the coordinates for E, and oh, I see. So if those are the coordinates for E, then Let's see. Oh, I just saw a comment. No, it's because if this is s, then the diagonal of the square is s root 2. It says s root 2 plus r, s root 2 plus r. Okay, okay. And yeah, Ken, I'm a complete wreck when I take tests. So, let's see here. Oh, that's interesting. Oh, we actually have a relationship now because, let's see here. So 9 plus root 5 over... Yeah, so I swear there's something you can do here because there's a... We're trying to find the ratio of r over s. So AE what am I missing? Well, the coordinates of f I feel like I'm like a step away. I'm not sure why I'm not seeing it. Root 9 plus 5 root 2. Let's see, E. What if we used vectors? I like your tip, Ken, but my issue is I haven't yet been able to write an identity involving S and R that I would use to even compute their ratios. That's the issue that I'm having. Oh, wait. I can figure out the length of AE. I totally can, because I can get the vector AE by subtracting the point E from this point 0s. So this vector is going to be s root 2 plus r, comma, s root 2 plus r minus s. So that's going to be this vector that I've drawn over here. And so the length of this vector is going to be x squared. I'm just going to do the length of the square of the vector. So you have 2s squared plus r squared plus 2 root 2s r, then plus, what a mess. So this is going to be r minus s quantity squared is going to be r squared minus 2sr plus s squared. Let's see. There's that plus 2s squared, and then plus, oh, this doesn't scroll down, 2s root 2 times r minus s. Okay. This quantity, there it is, this quantity plus r squared should equal 9 plus 5 root 2. Okay. So somewhere hidden in here is the answer to our question. So let's group the terms. So 2s squared, how many s squared terms do we see? I see this one, I see this one, I see this one. So that's 5s squared. Oh, there's more. DoorDash. Hold on, I need to like stop my phone from sending notifications to my computer. Let's see. Okay. me make sure I did it correctly. So yeah, this vector is s root 2 plus r, s root 2 plus r minus s. Okay, now I actually think I can use the suggestion that Ken gave. So I'm cheating at this point. So I can set s to 1 to compute r over s. So let's see. So it would just become 2 plus r squared plus 2 root 2 r plus r squared minus 2r plus 1 plus 2 plus 2 root 2 r minus 2 root 2 is equal to 9 plus 5 root 2. All right, let's see what happens here. So you get 2 so you get 5 minus 2 root 2. What are all the r terms here? So this is 4 root 2 r plus 2r squared. I think I messed up my math, to be honest, but I'm 100% confident the solution is in here. Anyways, I think I have only time to try one more problem. So let's see, which other problem should I give a shot to? I don't know why I'm opening my files. Let's see, which problem should I give a shot to? So 17 was a dud. So just 22 and 25. Let's see. 22, 25, and we were also unsure about 24. Let's see. Oh, I see, Ken. I see. I still think the answer is very close. How do you figure out the number of elements in a set? The number of ways to pick non-consecutive elements in a set. I think we should be able to figure this out. Let's see. Oh my god, I hit the power button on my computer. Or at least I thought I almost did. That would have ended the stream right there. Let's see. If I'm picking non-consecutive elements, then let's say I have just 1, 2, 3, 4, 5. How many? How about how many subsets contain consecutive elements? You know, this is a problem that I've taught before, so it's very embarrassing that I can't remember how to do it. Oh well. And then there was this one too, 19. We were really close on that one too. All right, you know what? I'm gonna call it. I'm gonna stop lollygagging. That's it. This is how I did. Let's look at the answer sheet. Let's see. Were any of you trying to do it along with me? Let's see, answer key. So it's A C B E D A B. Ooh, 8 was C, not D. I got that wrong. I don't even know how. Figure out what happened there. And then A, E, C, B, E, C. Let's see. Then 15. A, B, B, E, E. A, B, B, E. Ooh, I got 20 wrong too. 20 is incorrect. And E, D, B, D, E. E, question mark, D, D, E. Oh, got this one wrong. Got this one wrong. Oof. Guys. Oh my goodness. I got annihilated. Wow. Brutal. All right, let's see what I did wrong. Kind of curious. Let's see here. I guess that's life. Sometimes you just get annihilated. 8 was D. How did I mess up 8? That was a very early problem. 8 was... How many... Oh my god, I selected the wrong answer. I said 4. No, wait. 8 is... Wait, it's C? Hold up. 1 of 2 or more consecutive integers. Oh no! I counted 15 alone because I thought it was just 1, not... Oh, that's brutal. Okay, alright. Let's see here. 17. How did I mess up 17? What was 17? 17 was this one. All right, let's see how close we were to 17. I'm very curious. Come on, dude. This is exactly what I said. What did I do wrong? R squared. Oh my god, I set the wrong side to be the hypotenuse when I was doing Pythagoras' theorem. Oh. Yeah, that's why nothing was working out. And thank you, Muhammad. I appreciate it. Yeah, I set like I set AF to be the hypotenuse when AE was the hypotenuse. Otherwise, there would have been a mass cancellation that happened at the end. All right. Let's see. 20 was C. How did I get 20 wrong? That's actually one of the ones I answered. Let's see. 20 was C. Wait, I did get 2 over 243. Wait, 20 is C. I said C. Okay, I guess I'm just being mean to myself for no reason. I actually got 20 right. Okay, all right. 22 was, what is 22? Oh my god, this one. I'll look at this one at the end because this is the only one that like completely flummoxed me. I had no idea how to do 22. I'm very proud of it. I got 23 though. That was good. 24 is... What is 24? Let's see. 24 is D. What did I do wrong? Okay, so I just needed to add all of the odd numbers. Wait, I needed to add all the odd numbers 1 through 2007. Oh my goodness. I completely forgot if you add odd numbers, you just get squares, because like 1 plus 3 is 4, 1 plus 3 plus 5 is 9. So it actually should have just been 1004 squared. Oh my goodness. Where is 19? Did I forget to do a problem? Oh my goodness. And I also forgot to do a problem. Let's see. 19. Oh yeah. This is the one I couldn't do. This is the tangent one. Let's see what happened here. Oh my god. I had this one. I even had the right... I had everything right. Why didn't I finish this? I think I just got lost. I think because the numbers were so nasty, I just didn't believe in myself, is what happened. Brutal. But yeah, I got negative 38 over... Yeah, I just looked at the negative 38 over 5, and I was like, dude, I'm backing out of this. No good comes out of a negative 38 over 5. Oh my goodness. Okay. All right. That's why I thought 20 was wrong. Absolutely. All right, man. All right. Let's see what else I messed up. 22. Oh yeah, 22 I'll look at the end because yeah, like I said, it's the only one I had literally no idea about. 24 I just bad arithmetic. So I think a lot of these boil down to a loss of confidence or bad arithmetic, to be honest with you. This one, actually, let's see. No element in our original configuration. For each configuration, we can subtract I minus 1 from the ith element. In your subset. I'm not sure what the solution is saying. Let me read it one more time. We want to choose k numbers out of n with no consecutive numbers. For each configuration, we can subtract I minus 1 from the ith element in your subset. This converts your configuration into a configuration with k elements where the largest possible element is n minus k plus 1. I see, I see. Okay. That's how you do the conversion. Yeah, I completely forgot how to do this. Crazy. So they're saying that if you have a set that you've picked with no consecutive elements, you can just add like for example, let's say I pick 1, 2, 3, 4. Right now this has consecutive elements as a subset of 5, but I can add 0 to 1, 1 to 2, 2 to 3, and 3 to 4. And this will push the elements apart, essentially. And this creates a bijection between the sets that have consecutive elements and the ones that don't. I feel like I should have got that one. All right, I'll stop making excuses for myself. I hope you enjoyed that. I want you to know that that was unbelievably stressful. Like, I cannot believe how stressful that was. I'm just like, I'm sweating through my seat over here. But I appreciate those of you that stuck around. So yeah, that is clever. I have to say I've taught that trick before, and I completely forgot it. So, yeah, I don't know what to say. Look at 17. Oh yeah. I completely forgot about that one. Look at 17. Let's go. Oh wait, no, we already looked at 17. And thank you, Ken. You're being very kind. I think the lesson is if you want to if you want to get good at math competitions, don't get a PhD. You like pour all your points into like fancy math, and then you get worse and worse at basic math as time goes on. Let's see. So Muhammad, I believe that we yeah, that's right. 22. So you're thinking about the one with the this one. Let's take a look at the solution. Project any two non-adjacent and non-opposite sides of the hexagon to the circle. The arc between 2 points formed is a location where all 3 sides of the hexagon can be fully viewed. Since there are 6 such pairs of sides, there are 6 arcs, the probability of choosing the point is 1/2. The total arc degree measures add up to 180. I don't think I would have come up with that. I don't think I would have come up with that. I see. So you need to project any two non-adjacent or non-opposite sides. So for example, like this side and this side. And you project them to the circle. And then the arc between 2 points. And yeah, you just set that equal to 1/2. All right, I've already been here for 90 minutes. So I should probably go. I try to keep my stream somewhere between like an hour and an hour and a half. Hold on, my like vacuum is going crazy. Okay, I've turned off my vacuum. All right, I think that's it out of me. I need to take a cold shower now. All right, so Mother Reed says, can you make the next stream about proofwriting? I did my bachelor's in engineering and began to like maths once I completed my degree, so I never wrote proofs in uni, and I'm trying to change that. Why not? We can do the next, what type of proofs? Just proofs in general, or like, yeah, please let me know if you have any requests. As of right now, the audience is pretty small, so you can so the first 45 minutes, Ken, was pretty, like, the easy part of the questions. So, yeah. And yeah, sure, why not? I can do something about proofwriting. I'm not sure if it'll be like the next stream, but I'll definitely do something about proofwriting. And regardless, I want to thank everyone that did show up and accompanied me on this incredibly stressful reliving of my past. And sure, why not? Maybe like next stream or like next to next stream, I'll do something about proofwriting. And thank you all once more, and I'll catch you next time. All right, peace.